All right, we're going to start. So if you go with section P is really a review of what you have learned so far. Just make sure you know all the basics. Okay, so we're going to go ahead and go through those, and hopefully all that nice, very good knowledge that Mr. Dowell has taught you that you flushed away during the summer, we'll try to go ahead and get that back. That's what this is about. So in section P, again, we have P-1, real numbers, P-2, 3 all the way through 7. Again, I am going to cut it off at P-4. So from P-1 to P-4 will be our first quiz. Okay. P-1 is real numbers. Okay. P-2 is Cartesian coordinate system. P-3 is linear equations, inequalities. P-4 is lines in the plane. Okay, so that's what we're going to do. So let's go ahead and open your books to page 2. P-1, real numbers, okay? Can anyone tell me what a real number is?
A rational number?
A rational number, okay. A rational number is a real number. Anybody else? In other words, what is a real number is a number that is not a blank number. What goes in that blank? What is the opposite of real number? Sam?
Imaginary numbers.
Imaginary numbers, correct. So, real numbers and imaginary numbers, correct? All right, so all numbers can be either a real number or imaginary number. Okay, all right. Lila, give me an example of an imaginary number.
Anything with an I?
Correct, very good. Anything that looks like this is an imaginary number, correct? Where I being what? What is I? I is this, right? I is this, okay? I is the square root of -1, which does not exist. And that's why it's called an imaginary number. Within real numbers, what do we have? We have, what do we have?
Integers?
Oh, you have integers, okay. We have numbers that look like this, right? We have numbers that look like this, right? Numbers that look like this, and we have numbers that look like this. Or actually, I should say, we have numbers that look like this. Anyone tell me what kind of number this is? What is this? Kyle, what is this?
I don't know.
It's a fraction, isn't it? 4/7? 4/7? It's a fraction, right? These are called what? Caden, what are these called?
Fractions.
Fractions. They're called rational numbers, right? Rational numbers. The one that root 5 is what? If this is rational, what are these?
Irrational.
Irrational, correct. Irrational numbers, okay? A rational number is a number that can be put in the form of A over B, where A and B are integers. Okay, that's what a rational number is. An irrational number is a number that you cannot do that. Root 2, okay? 1.4-14, blah, 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 okay? It continues on, and this does not repeat itself. It looks like it repeats itself, but actually I think this is a 7, and it goes on and on and on. Okay, it does not repeat itself. It's an irrational number. Okay. All right. If it repeats itself, if you have a repeating decimal, what does that mean?
It's irrational.
Okay, if it repeats itself, it's actually a rational number. Okay, so those of you who had pre-algebra with me, Brooklyn, did you have pre-algebra with me, right?
No.
No. What did you have with me?
Mid-high math 2.
I had to. Okay. In pre-algebra, you are taught that 0.3333 and on is equal to what? This is 0.3 repeating. Can anybody tell me what the fraction form of this looks like?
1/3.
1/3, right? This is the same as 1/3, correct? So actually, this is a repeating decimal, which actually is a fraction, okay? What about 0.11111? 0.1 repeating is what? Anybody tell me what this is in fraction?
1/9 or no?
1/9. Good answer. 1/9. The way this works is this, and I've talked in pre-algebra where we talk about this. If I have 0.47 repeating, this is the same as 99/47. If I have 0.125 repeating, this is the same as 999/125. Can you see the pattern here? If I have 0.1 repeating, this is 1/9. In other words, if I have one digit that's repeating, I put a 9 underneath here and 1 goes over here. If I have two digits, it's 99 with the 47 moving up here. If I have three digits, it is 999 with the three digits going up here. Okay? And in pre-algebra, we talked about this. Okay? So that's how you convert a repeating decimal into a fraction. Okay? If you're wondering if this is going to be on the test, this is not going to be on the test. I'm just kind of trying to bring back that memory that you learned in pre-algebra, or supposed to have learned in pre-algebra. Okay? Okay, so we talked about the numbers. There are also, if you look at the very first page, there's what is called the natural numbers, whole numbers, and integers. Okay? So we have natural numbers, we have whole numbers, integers. Okay? Natural numbers are 1, 2, 3, on and on and on. Whole numbers is the same as natural numbers, but you start from 0. Integers, you include the negatives. That way, okay? We've learned this all before. Again, on the test, I am not going to ask you what is a whole number, and you have to say this, okay? That's not really important. As far as I'm concerned, it's not important. Okay, example 1. Blah, 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 decimal form of itself. Okay, we talked about that, how to work that out. Okay, it actually doesn't even go over that really. Okay, and then we talk about the number line, how to order numbers. Okay, if you can't tell, if you don't know that negative square root of 3, the negative of square root of 3 is less than 0, you're in the wrong class. Okay, order and interval notation. There's a blue box there, bottom of page 3. Go ahead and look at that quickly. See if there's anything I need to go over. Any questions there? Let me know. If not, go ahead and flip the page. Go to page 4. On the top, there's a blue box. Says the trichotomy property. Let A and B be any two real numbers. Then one of the three things has to be true. A has to be either smaller or less than B, or they're the same, or A is greater. Well, that kind of makes sense, right? What's more, I guess, more interesting is the notations in the inequalities, the notations. So if I had a notation that looks like this, how do I read this? Ezekiel, tell me how I read this.
X is greater than -1.
Or?
X is less than or equal to 2.
Correct. Very good. Okay, so it's actually not or, but it's and, right? Because both of these have to be correct, right? So there's a couple of ways that we can notate this, okay? First one is using brackets. When we use brackets, we're going to use either this kind of brackets or this kind of brackets or a combination of those, okay? So this is actually going to be, the notation that I'm going to use here is going to be -1 and 2, okay? So this type of bracket indicates that it's an open boundary. In other words, this boundary here, the boundary number -1 is not included. In other words, there is no equal sign here. Okay, on this one, the hard bracket, it's 2, but the 2, the end point is included, meaning the equal sign is there. That's why we have this type of bracket. So if I drew this on a number line, how would I draw this? It would be -1 and 2. I would have 2 as a closed dot, 1 as an open dot, and it would be intervalling between here, correct? All right. Another way to notate this is to say -1 and 2, and I would close hard bracket here, open bracket here, and go like that. Okay. All right. So, we're good with that? Any questions there? That is on page 4, bottom of page 4. Bottom of page 4. And so these are all bounded because either way, you have a number that actually signifies the end points, okay? Sometimes you're going to have things that look like this. X is greater than or equal to pi, okay? X is greater than or equal to pi, okay? What happens so we have on one side, we have a boundary, but on the other side, it's all the way open, okay? So with that time, for that kind of stuff, we would say, since it's greater than pi, it is that, and it is included because there's an equal sign here. On this end, we're gonna say infinity is unbounded, right? Even though it looks like there's a boundary there, since it's infinity, there is no boundary on the high side, okay? And that stuff is located on page 5, middle blue box. Unbounded intervals of real numbers. Unbounded intervals of real numbers. All right, any questions there? No questions. Let's move on to basic properties of algebra. So before we go there, I'm going to give you guys a quick 3-minute break. So it is 11:08 at this time. Do not log out. Stay logged in, but go take a break or whatever. Come back by 11:12.